please take it away. Microprocessors, Rick, yours.
Okay. So yes, I am Rick, WA6NDR, for those of you that don't know me, and I'm retired, but for most of my career was a software engineer. Now computer programming is a hobby instead of a job, and the last 3 years I've gotten particularly interested in programming microcontrollers, and that led to this talk. It's going to start with some very broad related subjects and there narrows in on one device. And everything I mentioned can be looked into further in the links in the handout. That handout has a lot more information than I'm going to cover. I'm covering about 20 of the 40 plus links that are on that handout. I'll mention them all, but a lot of them just get a sentence or so in passing. A Zoom tip, I'll be going back and forth from sharing my whole screen to the camera here. So what I've found useful is choosing one of the view settings on computers. They're in the upper right, that is side to side speaker or gallery. And that allows sliding how big the two images are during the talk. And you can either make my screen very big or me very big when you want to. So anyway, just a Zoom tip, view side by side. One of those settings I think is really useful. I won't see raised hands or icons or the chat screen. So if anybody wants to interrupt, speak. And so I think that's it. Let me get started and share my screen. And you can look at your handout if you want to follow along to where I'm going. Okay. There. So this is the first link, and I want to spend a little time here. This summarizes 53 years. So let me go over the axes. This on the bottom goes from 1970 to 2020. 2024 would be out about where the right margin is. And then the vertical axis is a logarithmic scale showing transistors on a chip. And so every equal increment here is a factor of 10. This is 1,000, 10,000, 100,000, million, 10 million, 100 million, billion, 10 billion, 100 billion. Okay. I don't know if you can read them, but these various dots are microprocessors. Way down here in 1971 is the Intel 4004, and that had 2,300 transistors on it. And that was considered to be the first commercially available microprocessor. So remember that number, 2,300 transistors. And then back in the late 70s, early 80s, it was a very big deal when every microprocessor came out. We've got the Motorola 6800, the Intel 8080, the Z80, 6809, 8086. So that's the IBM PC, Motorola 68,000. That went into a lot of HP products that I've worked on. 8286, 8386, and here is the Pentium 1993. And then it just goes crazy with things all the way up to, there's not a point there, but hopefully you can see my mouse. Way up here in the upper right, in 2024, NVIDIA came out with a graphics processor unit, a GPU, that had 208 billion transistors on it. So in 53 years, we've gone from 2,300 to 208 billion. That is a multiplication of around 90 million. So in other words, on a single chip today, you can put 90 million 4004 processors. It just blows my mind when we think about where we've come. And so the question I'm going to address now is, so what can you do with this technology? And one aside, this link, if you go to the Wikipedia page that it's actually from, it's a Wikipedia page called Transistor Count. That page talks about all the technology that went into climbing up this curve. So if you're ever interested in that, it's what allowed us to get smaller and smaller and smaller technology and all from 2,300 to 208 billion transistors on a chip. The next thing on the outline, I am not going to go to any of the three links, but it's terminology. I want to talk about what they are. I'll just mention it. A microcontroller is a chip. We're only going to go into one in depth in this talk. A single board microcontroller, we're going to browse through many. I'm just going to page through Raspberry Pis, Arduinos. There's a lot of single board microcontrollers. I'm only going to take one of them to depth, but you're going to see a bunch of them. And then lastly is single board computers. And when you see that, do think of a desktop or a laptop all in a little board, maybe the size of a deck of cards. And imagine hooking up to it a monitor, a keyboard, a mouse, a speaker, various USB peripherals and all that. But these single board computers are now about the size of a deck of cards. I do want to have one slide on the global market, and you have this link too, but the microcontroller market worldwide is about $32 billion. And this first, by the way, can you all see my mouse? It's on the pie chart right now.
Yes, we
Anyone
can.
answer?
Yes, we can.
Okay, you can, good. About a quarter of this $32 billion pie chart is consumer electronics and telecom. And so that is things like watches, toothbrushes, hearing aids, washers, dryers, refrigerators, car key fobs, cell phones, cars. I looked this up. The average passenger car has from 25 to 100 processors in it in various locations or microchips. And I thought that was amazing. So everything is talking to everything in your car. And so anyway, these microcontrollers are everywhere. And we're going to focus on their use in hobby electronics, which is one part of this quarter of a segment here. I'm going to leave this slide up, but just talk about the next thing in the outline, and that's the future of hobby electronics. If you ever want to read it, there's a link there to an article that I found very interesting, but it talks about 4 different things culturally coming together that have changed 10 years. And that's Internet of Things, 3D printing, the maker movement, and physical computing. And I want to talk about each of those. The Internet of Things, and there's a link to that in Wikipedia, is just the fact that it is trivial nowadays to put any project on your home internet. And not even your home internet, but also, if you do the right things, internet control anywhere in the world. So I don't know, when we get to the end, Matt, you might want to talk about what you've done with your house and what you can do remotely from your phone anywhere in the world. But Internet of Things is just that everything can be on the internet now. Don't just think of it as computers, but home light controls, cameras in your house, your Ring camera at your front door, anything. Internet of Things. 3D printing, Matt's done a lot on this lately, but anything that you need for a little project, a stand, a gear, or whatever, you can now make yourself. The maker movement is a big deal. That culturally is schools and hobbyists are now doing projects. I'm going to show you 11 pages of progress on the web in a bit that are just bizarre things, bubble blowers, dog feeders, automated this, automated that. So, and lastly is physical computing. You got to start thinking of these projects you can do as a microcontroller with inputs and outputs in a real world environment. So those might be as inputs, sensing sound, sensing voice, having a camera and seeing what's moving around you, ultrasonic distance sensing, touch. You can actually tell when this device is being touched by someone, and anything analog to digital. So anything you've got that's a variable voltage, you can always measure that voltage and respond to it. Outputs can be things like sound, voice, motors, servos, lights, displays, and anything digital to analog. So in other words, any kind of wave shapes you want to make, ones and zeros to turn things on and off. And then all these devices now, I mentioned internet, but they all have Wi-Fi and Bluetooth. So you don't even need to be connected to anything physically. You just with a battery, and if you're in a Wi-Fi environment or Bluetooth, you can communicate that way. So anyway, that's this market. Next up, I'm going to talk about Raspberry Pis. Now, this is one family of products, and I'm going to go to the Wikipedia article, and I'm skipping some of the links. There's a link there to Raspberry Pi, the history of the organization and that stuff, their home link. I'm diving right into hardware. And so on Wikipedia, there's this really good that you're looking at right now. There are actually 3 different series of boards, and then within each of those series, there are generations. The first one is just called Raspberry Pi. The second one, by the way, we're going to get to is Raspberry Pi Zero, and the third one's Raspberry Pi Pico. But back in the world of Raspberry Pi, this started in February of whoops, didn't want to do that. February of 2012. And that was when the Raspberry Pi Model B came out. And then it has progressed through the years to the Raspberry Pi 5 that just came out in 2023. I'm going to be showing in a little bit the one single board computer, that's what all these are, that I have, which is a Raspberry Pi 4. The Raspberry Pi 5 is very similar. The Raspberry Pi Zero came out in 2015 for $5. So just wrap your mind around that. This is an actual microcontroller. It has a lot of I/O. It can do things. In fact, I'll show on your camera. Let me make sure I can see mine. It should be able to see my camera. This is my Raspberry Pi Zero hotspot. So inside that box, there's a Raspberry Pi Zero with a top board that is a radio modem, and that's a hotspot. So that's my hotspot for ham radio is a Raspberry Pi Zero. Anyway, the board costs from $5 and up. They've come up with several models since 2015 all the way up to 2021. And then the Raspberry Pi Pico is a true microcontroller board. It's not a single board computer. It is a small microcontroller board with I/O. In January 2021, it came out with a price of $4 and has advanced up to $7 through these various models in 2024. Here is a comparison chart in Wikipedia too, not too big, of all of the official Raspberry Pi boards. So I wanted to go over that in the way of hardware. And then that kind of gives you an overview. This page that you have a link to is Raspberry Pi's Buy From Us page. So you can kind of see how many pages long this is. I'm just going to page through it quick. But all that hardware we just saw overviewed is available here. The single board computers, the Picos, there's lots of other products that they sell here too. So lots of hardware. The point I'm trying to make is that it's hard to wade through all this stuff. Next, just one suppliers of Raspberry Pi add-on boards. So this is from Adafruit, and you have a link to hats and bonnets, and that's what this link is. 77 hats, that stands for hardware attached on top. So these are boards that you can actually plug right on top of a Raspberry Pi board. And then bonnets are just smaller versions of hats. They have less pins. But anyway, 38 of those. So just look at how many of these things are. This is from one supplier, Adafruit. And again, I'm just going to page through them and kind of look at the pictures, look for anything interesting. There's an LED matrix. That's kind of neat. This is servos down here. So there's one that can drive servos. A keyboard, touch screen, what else? I thought this was cute. There's two LCD displays and you can make them into eyes that look around. So if you're making a robot or something, you could actually track people with that with a camera and this, you can make it look like the eyes are looking at them. What else? Displays, tilt. There's the computer sensing its orientation and lighting lights in response. So as you tilt the display, it's going to light up more or less lights. I'm trying to get you to just think about the types of things you can do with these devices. More servos. There's a Mario game. What else? On and on and on you go. Oh, this is an electronic organ, so it can tell which piece of fruit you're touching and will make sounds in response to it. On and on. And like I say, this is from one supplier. This is Adafruit. Okay, you get the idea. There's a lot of stuff out there. That's all the world of Raspberry Pi. I want to now show you, let me go off of screen share for a minute. Okay, this is a Raspberry Pi 4. So notice it is the same size as a deck of playing cards, a little bit thicker. That's it. This one's in a case. This was one I just got about a month ago for $70. And there's a link at the end of your handout to this particular thing that I bought from a company called Vilros. And I'm going to go over its connectors. On one end, it's got a LAN connector, 4 USB ports. Turn it. This is a 3.5 millimeter 4 conductor left and right audio and composite video out. So to drive like old style TVs, remember the RCA jacks that are white, red, and yellow? That will drive that to directly to a TV set. This is 2 HDMI ports. These are micro HDMI. It comes with an adapter to convert micro HDMI to HDMI. But this will support 2 monitors out of the box. This is power. It came with this power supply. What's that? So everything I'm showing you for $70. This is a Raspberry Pi 4. And then on the bottom right there is a 32 gigabyte micro SD card. That didn't come with it, but that is its entire mass storage. That is essentially its hard drive. And that's it. The only other thing is a fan keeps it cool. And that's the case. Okay. So that's a Raspberry Pi 4. Let's see. What else did I want to say about that? Yeah, let me show you some, go back to screen sharing and show you some things related to that. Okay. And okay, let's maybe go back. This is some screenshots I captured. So let me say too, I use my Raspberry Pi 4 with a wireless keyboard. So that's a wireless keyboard that has a trackpad. So there's my keyboard and mouse wireless and a Bluetooth speaker. That little box I showed you has both Bluetooth and is on my home Wi-Fi via Wi-Fi. So I don't even have to connect up a LAN to it. So what you're seeing right now is what I got when I connected the keyboard, the speaker, and Wi-Fi all remote. So the only thing on the Raspberry Pi was an HDMI monitor and the power supply. That's it. And this is what it turned on to. That's the first screen I ever saw. After a little bit of configuration, it looked like this. I moved the taskbar down to the bottom, and this is just going to take you through its highest level start menu. It came loaded with a programmer's editor, a Python integrated development environment, two different web browsers, Firefox or Chrome, and this is a reduced version of Chrome. It's called Chromium. The VLC media player, an image viewer, a bunch of accessories, including File Manager, which I'm going to show you. Lots of help resources and a preferences menu. That's where I just went through and found things I could customize. And I liked the blue background instead of the picture and set it up for that. And that's it. And you can then go out on your web browser and find software and download software, things like that. This is the file manager. It looks a lot like Windows. And there's, in fact, a bunch of screen captures that I captured. They automatically went into my home directory, Rick Pictures, and this is what the screen captures you're looking at are. Next, I was surprised at how easy this was. I transferred over a Python program that I wrote that makes a tree, and it ran. I mean, it automatically scaled everything and it just worked. So this is that Thorny integrated development environment. So that worked. I installed a couple old retro games. So I installed Pong and played it. I installed Frogger. That's that. And this is the last thing I want to share from the GUI. So you can see over here on the left, it was very easy to put things on the desktop. I moved the Python IDE over here, Task Manager, Firefox, a calculator, the two games I installed, and I left up these two windows to show you that Firefox, it was very easy to transfer over all my bookmarks. I just exported them on my desktop and imported them from that file. And then lastly, I want to spend a little time over here on this terminal screen. Just like Windows is built on Microsoft DOS, and you still have on your computers the DOS command prompt, Raspberry Pi is built on Linux, and you have built in a bash terminal. That's what this is. So it has a lot of commands just like the Windows command prompt, dir for a directory, CD to change directories. Here, dir is ls, that's a Linux command. Find is look for files. What else? Cat is display a file. What else? Echo is the same as DOS, actually. That's just echo, Merry Christmas. Lots of things. So this is now Linux. And you can essentially do everything this computer will do through this terminal remotely on another terminal. So just what you're seeing right here will also exist on my Windows desktop that I'm in front of right now. And I can control everything on the Raspberry Pi from that without the graphical user interface. So these things are extremely flexible. Okay, I'm going to stay in these photos for a second. This is a photograph of my Raspberry Pi inside that box. And I want to just go over what's in here that you can't see when it's inside the box. So just to get a scale, over here on the right is a LAN connector. This is a stack of two USB ports, a 3.5mm 4-conductor connector that does audio and composite video out. This is two micro HDMI outputs, power. Right underneath here is the SD card that's on the bottom. And then I want to talk about now what you can't get when it's in the box. This here is a 15-pin camera connector. So if you ever want to put this board on a robot or something, a ribbon cable will connect right here to a little micro camera that's about, an inch in diameter. And it's just a ribbon cable connector, and now your robot or whatever you mount this on has a camera. Similarly, over here is a 15-pin connector for a display, and that can be a liquid crystal display to show text. It can be a dot matrix display and show graphics, but this is a ribbon cable to, again, something that's probably 3 by 3 inches or smaller, 2 by 2, 1 by 1, that kind of a thing. This 40-pin connector, I've got another slide on. This is an amazing connector, and it's universal throughout the Raspberry Pi family. They haven't changed the pin out, but I'll talk in a second about what you can do with that. And then lastly, the last thing that's internal is this PoE 4-pin connector. This is power over Ethernet. So if you want to have a bunch of these things connected somewhere by LAN cable, one cable, a LAN cable to here, will both power the board and give you complete remote access to everything it can do through a terminal interface. Excuse me. So anyway, that's what you get if you take the board out of the box. Let me now show you that connector. Oh, there's the bottom of the board. I forgot I had this one in there, but that shows the micro SD port. Okay, here is that 40-pin connector. I'm not going to go over it in detail, but it has ground, power, um, these, I'm glad everything's color coded because I don't care where they are, but this purple stuff right here, notice it says I2C. That is an I squared C interface. It is power and ground and two other pins. That's it. And I'm going to show you some devices I have that work on this. So 4 wires, keep that in mind. 4 wires can completely control 7-segment displays, 14-segment displays, graphics displays, all sorts of things. That I squared C stands for inter-integrated circuit connection. Inter-integrated circuit is what the IIC is. So that serial bus will control a lot of different things. Next, this SPI bus is serial peripheral interface. A lot of other chips require it. It is a 3-wire, much higher speed bus. So again, power and ground and those 3 wires, 5 wires total, do the whole job. And let's see, these are auxiliary on that. Other things, all this GPIO just means that's general purpose input or output. You can either put input a 0 or a 1 or output a 0 or a 1. So if you want to do 8 or 16 bits, I think there's 16 total. Some of them are dual purpose. So this can either be GPIO or these things, completely configurable. So this is a world of input output, and you can do a whole lot of things with that too. Okay, that's all I wanted to show from my photos. Let me go back here. Okay, go back to this. Okay, let me catch up on my outline and see where I am. Okay, anything else about Raspberry Pi I wanted to say? Nope, that's about it. Do any of you want to say anything about Raspberry Pi before I continue on to talk about Arduino? Anybody?
Raspberry Pis are awesome.
Yeah,
I have a
I've had
bunch
a
of
lot
them.
of fun playing with that Raspberry Pi 4, and I would say, it's not a great place to start if you want to learn programming, but if you just want a cheap computer, I was amazed at how good that GUI is at turn on. I could install software, I could do Python programs, and yeah. And the terminal, I know Linux, that's actually what I used at work for years, but it's pretty easy to do stuff on the terminal too and use it. And there's a lot of websites that teach you how. But yeah, I
Yeah,
found a lot of fun playing with it. Go ahead,
yeah,
Matt.
they do quite a bit. I've got 8 Raspberry Pis. I've got a Pi Zero. I've got 4 Pi 3s, 3 Pi 4s. Um, we'll have to get together sometime so I can show you all the stuff I've done on Raspberry Pi.
Yeah.
I've got
Anyway,
one.
these things,
Oh, go
uh,
ahead.
Matt, what have you used yours for? See, I've just used mine to play with in the box. That's it.
So
But
I've
you've
got
done some, yeah.
yeah, I've got well our Echolink, our VHF Club Echolink is running on one of my Pis. Pi 3B Plus is running the Echolink audio in and out and the computer controller for that. I've got a Pi 3B Plus running my video file sharing. So I host video files locally on my LAN for like the girls watch movies and stuff on it on my Plex. my Plex media servers on one of my Pis. I've got one of them being a Pi called a Pi hole. So it goes between my modem and my router, and I've got a bunch of scripts running on that Pi hole, and it blocks all advertisement, all adverts that come in through just web ads. So on my laptops, all of our tablets, all of our phones, anywhere a website would have an ad, it just rips that ad space out of there. There's no blank frame or anything. It just completely deletes it, and you're just left with a clean fluid web page, which is really nice. And then I've got 4 Pi 4s, no Pi 3s, 4 Pi 3s being a Pi cluster, all 4 of them tied together, working as one. So, but
Neat.
I got quite a bit. We should get together sometime and play with them. That's really fun.
Yep. Yeah. Okay. Sounds good. I'm going to go on then to Arduinos, and what I want, I'm gonna, let's see, only do one link here. Let me go back to my browser. Hold on. Okay, are all of you seeing my browser now?
Yes.
Okay, good. Okay, Arduino. My summary of Arduino is it's similar to Raspberry Pi, simpler. It's generally not a single board computer. It is a single board microcontroller. So it's kind of the low end of what Raspberry Pi can do. And less money, um, better for simpler hobby projects. One thing is, I'm going to get to this later on, the world of Arduino programs in C and C++. Now, if you enjoy programming and want to learn a programming language, C and C++ is a commonly used language, and you can learn it. But that's it. Raspberry Pi is primarily Python. It's a lot easier, I think. And when I get to something else, there's even easier languages than that. We're going to talk about it. But I don't have much to say about Arduino. I'm just going to go through the hardware here that you're looking at now is on the Arduino homepage, their hardware. And as I page through it, it's just a lot of what you've seen before. There's Arduino boards that are comparable to Raspberry Pi boards. Generally, I would say if you're on Arduino, probably you have a project that specifies an Arduino and you want that software and it'll run on one of these boards. But if you just want to learn, either one's fine. Arduino, if you want to do C and C++, Raspberry Pi, it'll do C and C++, Python is kind of its main built-in thing, and it'll do other languages too if you load the right software. And let's see, I did want to show now, I'm branching into Adafruit. That's the next one. This is a company called Adafruit, and you got links there I'm not going to visit, but the first link on Adafruit on your handout is the Wikipedia page that goes into the company history and all that. I gave you their home link, which is their products and what they're selling and pushing right now. And this is the Raspberry Pi hardware page. And I don't know if you can see it, but my scroll bar up in the upper right, this is probably 15 pages of hardware. And I'm just going to go through it quick. This is all Adafruit, but Circuit Playground, Feather is a whole line of their processors. Raspberry Pi, that's things that go on Raspberry Pis. Microbit, that's another one. Particle, Bluetooth, Arduino, accessories, batteries, books, breakout boards, cables, Circuit Python things, components and parts. This is an interesting world. Cosplay is costume playing. So when you've seen things like, oh, somebody can tell me what it's a big forum where everybody dresses up like comic book characters and has electronic hardware and lights on their costumes and everything. This supports that. Comic-Con, that's it. Thank you. You can build those outfits from these things. Development boards, electroluminescent wire and panels, Halloween things, Internet of Things. So all of these projects are internet connected. LCDs, displays, machine learning, microchip, NeoPixels. I just like this company. I've had a lot of fun just looking at everything they sell. Prototyping, wires, breadboards, probes, alligator clips, kits. This is great for schools and students too.
I think the good thing, Rick, about Adafruit is when they sell you stuff, they have a learn page for everything they sell. So if you need to learn how it works, they walk you through it.
Yep. And that's one of the reasons I'm about to start focusing on one product that Randy actually recommended to me 3 years ago, and that I thanked him for it. It has taken many, many of my hours, and then I branched out into other things. But Adafruit has great learning websites and, well, I'm not there yet. Let me continue with my outline. I also have a link there to many other manufacturers, and that is a link to this huge table in Wikipedia that I won't even show, but it's probably 20 pages long of a table just going through all the manufacturers. So it has in there Raspberry Pi, Arduino, and Adafruit, and perhaps a dozen other manufacturers of these microcontroller boards. So anyway, there's just many to pick from. And now I do want to branch into where to start learning. And this is where Randy pointed me and where I think is a great place. It is the Circuit Playground Express. This thing costs $25. It has great support. Anything you can imagine doing with it. There's a project or learning pages. It was introduced in 2016, so it's been around a lot. It's got a ton of stuff on one board and it programs in 4 different languages. Now I'm kind of into the programming, so I've spent a lot of time with all 4 of those languages. It has as inputs, just keep your eyes on that thing. It can sense light, the color of a piece of paper you put on top of it, sound, temperature, motion, orientation, touch on various of the pins around the outside. Infrared, it will sense remote controllers that you can fire at it and analyze them. It's got 2 buttons here and here that you can program to do whatever you want. A switch here, that's actually a left-right switch. And these pins, just like the Raspberry Pi, are completely configurable. They can do analog to digital, digital to analog. The various buses that I told you about, I2C, which is integrated circuit, and SPI, serial peripheral interface. It has an analog output. You can make it into a signal generator and generate audio, sine waves, square waves, triangle waves, things like that. It also has power supply and ground. So those external connectors are extremely configurable. Built onto the board, it has 10 multicolor LEDs. Each of these lights is a red, green, and blue LED, each with 8 bits of intensity. So this is like a single 24-bit pixel. You got 8 bits to set red intensity, 8 bits for green, and 8 bits for blue. You can essentially make any color of the rainbow is the idea. It has a beeper. It will emit infrared. What else? One cable connections. Let me talk about this. This is a USB cable. All your development is done with a single USB cable here to your PC that gives the board both power and bi-directional communication. So you can both talk to the board and get things back from the board on that. This down here is a power supply only connector. So once you're off the computer, you can power it with a battery like this. So this is actually an Adafruit battery to one of their devices. And that's just got 3 AAA batteries in it. That's what I use to power it. Okay, I want to talk more now. We're going to go to depth on this chip. This is one microcontroller, and I've looked into it. It's amazing. That little chip right there has 48 pins. It is 0.3 inches by 0.3 inches. It is for sale here. So this is a microchip site, and that's the chip that Adafruit uses on these things. It's manufactured by Microchip. They bought out the original manufacturer, which was Atmel, and that's why its part number is AT. It was originally an Atmel part. And that's what it looks like. So that's the microcontroller that's on the board right there. I want to go down here to pricing. So from Microchip, here it is. If you're going to buy 5,000 of them, like Adafruit would, they're from $3 to $4 a piece. And I'm amazed that you can get that much computation. I'm going to tell you what it is now on boards that are mass produced like this, 5,000 or more, for $3 or $4. First, I'm going to kind of go back and forth between two links. This is a block diagram of that microcontroller. Notice this one little block right here. This picture is pretty big. It's got a lot of stuff on it. This one little block here is called a Cortex M0 processor. Think of it as a 48 megahertz super Pentium. It is the microprocessor in this thing. It is actually created by a different company. That is a ARM Cortex core. You got to realize how nested these things are. This company, ARM Cortex, licenses microprocessor cores. Company buy the rights to put their silicon masks on their microcontrollers. So this is an ARM Cortex M. You can read all about it here in Wikipedia, and this is the Cortex M0. So on that microcontroller is this silicon die. It has a 3-stage pipeline, all these various features. It is a 32-bit hardware integer multiplier. It's got interrupts. It is used in all these microcontrollers. This thing is a super processor. It is, where was I again? That block of this block diagram. Other things that little 0.3 inch by 0.3 inch chip has on it is non-volatile memory from 32 to 256 kilobytes. And then think of that as flash memory. When you remove the power, it stays. So your program goes in that. It has from 4 to 32 kbytes of RAM. So when your program is actually running, this is what it's writing and reading. The only other things I want to really highlight is all of these blue boxes over here. These are various I/O devices that go to the various of the 48 pins. 6 general purpose serial communication things, 5 timer counters. So those are high speed timer counters. What's this? 20 channel, 12-bit audio to digital. That means here you can have 20 pins reading analog signals that are all changing from 0 to 5 volts and sample them at 350,000 cycles per second. Take 12 bits per sample and do arithmetic on it. I mean, think of what you can do with that. It's amazing. Analog comparators. So this is for measuring analog things, 10-bit digital to analog. So this will take 10 bits and generate an analog waveform from them. Again, this is where you get things like audio, sine waves, square waves, triangle waves, things like that. And the various bus controllers. This thing with these various devices can do SPI, I2C, and USB, by the way. So it can do all that. So that's it. There's the microcontroller board with this microcontroller for $3 or $4 that inside it has a Cortex M0 core that does all this stuff. So that's it. I just wanted to take this one device to depth. That's what's all's on this. Now, all these other parts are the various sensors and input output. Notice this is an eyeball. That is a light sensor. This is a temperature. That's a temperature sensor. This ear is because that thing is a microphone. This is a beeper. It'll make notes. And that's about it. So that's everything that's on here, and then all the I/O to control that stuff. Okay. I gave a link, let's see, to sample projects. So I'm going to start speeding up here. My time is getting about out. But this, various projects, you can make things here like costumes with lights on them, a cat treat dispenser. What else is interesting? This senses the orientation of the Circuit Playground Express and tilts a maze thing. Fancy looking stuff here. What else? Here's a hand orientation controlled robot. Notice he's controlling that totally remotely with his hand. Mount on displays, various things, an organ. This is one of 11 pages of projects you can do with a Circuit Playground Express, all documented, all with software provided. So anything you want to do, you pick a project that's close to it, download it, get it running, then modify the software. That's what I want to say about that. I also gave you a link in the handout to the base kit that I purchased. It's a Raspberry Pi plus battery pack like this one, plus USB cable, plus a little case for all of it for an extra $5. So it's $30. You've got that. Okay, I did want to go quick over programming and integrated development environments. So this is MakeCode. I've used this with two grandchildren, one 11 years old, one 10 years old. This Circuit Playground Express is currently connected to my PC, and this website is all you need to program it. So I want to stress, an 11-year-old can use this from scratch. Right now, you're seeing the program that's shown here on this board. It is a simple get it working program that just says blink the LED. The program says digital write a low, wait a second, digital write a high. Let me show you this interface. So for the Circuit Playground Express, the light menu has all the different things you can do with the lights. You can show animations, you can set all the pixels to a color, you can set a particular pixel to one color. Let me just modify the program here quickly. I'm going to say, here, set all pixels to black. Here, set all pixels to red. Then I'm going to say, just to see if it works, simulate it over here on the right. Okay, so now instead of one pixel, they're all blinking red and black. Now I'm going to reset the Circuit Playground. Okay, and say download. It says save it to there. Save it. Done. So now the Circuit Playground is running the new program. It's setting all pixels to black and red. It's as easy as that. I'm just going to take you through the menus quickly. You can do all sorts of things with the pixels. This is more you can do with external NeoPixel strips, like, I'll show that to you later. Don't want to get into peripherals yet. Inputs, you can do on button A, button B, both buttons, touch any pad. When they click, long click up or down, do anything. Light a light, make a sound. Music is built in, so this is the beeper. You can make sounds, melodies, tones, set the volume. Just got something on my watch. Loops. You have a forever loop, a start loop, This is getting into programming. This is what I taught my grandkids, but you can repeat a loop n times. You can do a loop while something is true. You can do an index, a loop, a calculated number of times. Loop control, logic, if-then statements, greater than, less than, Boolean logic, variables, math. Everything has a block. Everything here is converted to JavaScript. So this is the program we just wrote converted to what actually gets downloaded to the Circuit Playground Express. You can code here too. So if you want to learn JavaScript, you can code right here and do it in text. Everything that you can do as a block will convert to JavaScript. JavaScript is actually more capable than MakeCode. I'm going to show you one other program here. So I'm going to bring up where is it? Morse code. Here's a program that I wrote just to show how complicated you can get on this. Stop. This is a Morse code program I wrote. So you can see how big it is. Kind of goes on and on. Most of this over on the left is converting characters. You can see an array of A through Z and the digits, 2 dots and dashes. But all you do now is type in what you want to send, and I'm only going to simulate this. I'm not going to program it. We can simulate it. And there is Merry Christmas in Morse code. The buttons turn on sound, be ready. I think this should show up on your PC. Here it starts again. And then the other button just puts the LEDs through random colors. And all I have to do is download that and it'll run on the Circuit Playground. Okay, next. This is going to go quick. This is Circuit Python. One file change converts Circuit Playground from communicating in MakeCode and JavaScript to Circuit Python. So all I'm doing right here is saying, convert yourself to being a Circuit Python computer. Okay, now I can say, take this program and pass it down to Circuit Playground. This is a Circuit Playground program that says, blink the red LED and give me back some serial output. So if you look on the screen, the Circuit Playground Express is now, every time it toggles, the button's saying alive and kicking. So this is kind of like a hello world program, and that's all the code it took. So it just goes around and around saying alive, LED on, and kicking, LED off. The nice thing about Circuit Python, it is a interpreted language. So right now I am communicating on screen, look at the computer, with the Circuit Python. It can do things like mathematics, 2 + 2 = 4. It can execute Python statements real time. So if I say print hi, that's a Python statement. It comes back and says hi. That's going all the way down to the Circuit Python and coming back to the serial port. This is a Circuit Python integrated development environment. That's what that is. Okay, programming in C gets a little more complicated, and I'm not going to try and show that real time, but I do have some images that show that. And I think I lost my images. Let me go in here to here. Okay. Whoops. Okay, this is the integrated development environment for Adafruit. And this is a C++ program that I wrote. This is showing what the integrated development environment looks like after you've had a successful compilation. This shows that program actually running on a Circuit Playground Bluefruit. That's what this was made for. And I'm going to show you in a second that program running. But this is a C++ program. Down here at the bottom is the serial monitor. This was stuff coming from the device back to the environment. When you develop Arduino programs, this is what it looks like. That's, by the way, that's what the program makes. I'm going to hold on, got to go out of that. Okay, next I want to just show you my camera. Devices. This, let's see. Yeah, I got to go back. This is some I2C devices that I have. Notice there's 4 clip leads. Those clip leads can go to the Circuit Playground Express and put things on all 3 of those displays at once. Other hardware. This is a Circuit Playground Bluefruit. It's kind of like Circuit Playground Express, except it has Bluetooth I/O connected to a bolt-on display. I'm going to show you the program that you just saw is running on this. Okay. I'm not sure why. I'm not sure why that's working. Let's see. I do want to show another video. Hold on. Go back to photos. Doing things out of order, but I'm just concluding here. I must have closed that. Okay. This is those 3 displays that I just showed you being driven by a Circuit Playground Express, just showing what they'll do. They are all, of course, individual segments can be accessed too. So this is a program I wrote to just do patterns on them, learn how to do I/O. Okay, and that is all I have for that. And let's see, other hardware I want to show you. I think I'm getting about done. Oh, this is a, need to see what I'm seeing here. This is a Gemma M0. Notice the size of that thing. It's about 1/4. That also has a similar microcontroller on it and would control a strip of neopixels like this. Got to go back. You can't really see on camera the colors change that much. This is demonstrating a linear feedback shift register that I show to my students at SFCC. But anyway, it's colored pixels traversing the LED strip being driven by that little thing. Okay, and those devices, I do want to show them to you quickly, are on you have links to all of these. That is the newer Circuit Playground Bluefruit. It has Bluetooth connectivity. That's the gizmo I just showed you. It's a display that mounts on top of a Circuit Playground Express or Circuit Playground Bluetooth. That's the Gemma, the little 1/4 one, and that's a very similar microcontroller to the one that Circuit Playground Express has. NeoPixel strip, 7-segment display, 14-segment display, and 3-color matrix. So those are all the things I bought to go with this stuff. Back to you folks, and done screen sharing. Any questions?
I have a question. First of all, thank you for this presentation. It's really been fascinating, something I've been curious about for a long time. For someone like myself who has basically the only programming experience is BASIC back in 1988 or something, what would you recommend for someone who wants to learn to program these devices, and which language would you recommend it start with?
Well, one of the reasons I say Circuit Playground Express is it'll do it all and give you something to play with just with it. You don't have to buy anything else. And Circuit Python is very much like BASIC. It is an interpreted language. Back when you did BASIC, remember you can type at a terminal and do things like 2 plus 2 and it'll come back 4. That's why I showed that. It's interpreted. So when you send your code to the Circuit Playground Express, you are actually sending plain text. Your text file goes down there and it reads it line by line and will tell you if it ever runs into an error. What comes back is line 14 syntax error, or didn't expect this, or you forgot that, or something like that. So I think Circuit Playground Express and Circuit Python, that is where a lot of people start that did BASIC decades ago.
And Circuit Python, is that different from the Python that you mentioned earlier when you were talking about Raspberry Pi?
Yes, Raspberry Pi supports true Python. Circuit Python is a subset. It keeps it simple, but it's everything you want for hobby projects. That's why they call it Circuit Python. It's meant to control the circuit that you're running it on.
Okay, thank you.
Yeah, by the way, Circuit Python, I don't know if you caught this, but I downloaded a program to the Circuit Playground Express that I said, now it's a Circuit Python interpreter. That program was specific to the Circuit Playground Express. It put Circuit Python on that device. I've got another one that puts Circuit Python on a Gemma, another one that puts Circuit Python on the Bluefruit. And they've got slightly different interfaces because they got different built-in libraries when they go on it. But then it's easy for you to use that stuff. The language just picks up commands that are specific to that board. Any
Maybe
other?
I might add to that, if you don't mind, Rick, is the Circuit Python Express. The word express in there means that it comes already configured to do Circuit Python. So you really don't have to do much to start doing Circuit Python with an Adafruit microcontroller board that says Express in its name.
Right. That's Circuit Playground Express is
Circuit
Circuit
Playground, yeah.
Python compatible. Yeah, it
Right.
comes with it. Yeah. In fact, as I'm not remembering, isn't that how it turns on, Randy? If you just connect it to your computer, don't you see the Circuit Pi drive?
Yes.
Okay, yeah.
Yes. That's the way
So
it comes.
yeah, you actually
configured
have
like
to
that.
change it to make it do make code and Arduino, but it comes
Yeah.
ready to do Circuit Python.
That's why it's such a great starter if you do want to get started on it. It's just already configured to do that.
Yep. And Adafruit, like Randy said, I do when I want to learn something, I do Adafruit Circuit Python, then my question, and it gives you their answer to whatever you want. Yeah.
Okay, I got a question for you, Rick. Well, the kids these days, they do the programming with Chat GPT. So have you tried asking Chat GPT to generate any microcontroller code for you?
You know, I have asked Google programming questions and it comes back with an AI answer that's typically pretty good, but they're very narrow context. It's like, Circuit Python recursive Hilbert curve algorithm. That's one of the things I looked into, and it gave me one that was really good because somebody else wrote it. I think they just found it for me, but I have not used Chat GPT.
Okay, just curious. Thanks.
Yep. I have asked some pretty detailed programming questions of the internet, and Google comes back pretty intense, pretty good. Yeah. Answers my question.
One of the things that I might just throw in there is that Raspberry Pis are great. It's more akin to a computer, and the microcontroller is fun for electronics projects, and it's closer to circuits and wires and resistors and things like that. And one of the things that makes it that way is that it has an analog to digital converter on it. You don't get that on a Raspberry Pi, but all the microcontrollers have those. You pointed out the 12-bit A to D converters. So if you're sensing real world stuff, the microcontrollers are the way to go.
Yep. I tried to list that thing. And if you look at those project pages, it is amazing when you just, I can say things like, okay, it senses sound and light and orientation and things like that. But then what people have done with that is amazing. Little robots that do things. One of the things was I didn't pause on it, but I thought this was cute. Somebody made a thing with a servo that goes down into a soap solution and brings up a little wand and then blows air through it. So it goes dip, dip, blow some bubbles, dip, dip, blow some bubbles. It's just cute to watch this thing go. But yeah, lots of fun projects are on that projects page.
And one of the things that I did was it's always fun to do. Lots of hams probably know what a voltage divider is. And with just a couple resistors, you can measure almost any voltage. You just need to adjust the resistance on the resistors. And then you can connect it to that analog to digital, and you can measure any voltage you want. So I have one
Yep.
that displays my solar panel voltage, my battery voltage, that kind of stuff.
Yep. Hey, I've got something else to show now. This is working, but this, let me see if you can see that, is
Yep.
the C++ program. And this thing, from the time it goes off to the time it's going on, is calculating multiple sines and cosines for every line you're seeing. This is actually a pretty complex analytical geometry exercise that I did. And it's just to make snowflakes, pretty colored snowflakes. But I was amazed at how fast it's doing this. It's from the time it goes off to the time it goes on is all the calculation. And then it just pauses so you can see it. But just that blink off is calculating a new one, doing a bunch of mathematics. Anyway, so yeah, it's fast.
Hey, Rick, your LED light strip. you
What's
show
that again?
The LED light strip, the color chasing light strip.
What about it?
You have it. Pull that up real quick. Is it a 3-wire or
Oh, yeah.
4-wire? It's
Um,
they're digital, right? They're digital LEDs.
this is amazing.
Yeah.
So this thing, that's 3 wires, but it's power, ground, and 1 serial wire. I actually got into this big time and wrote an FPGA program for my class I teach at SFCC. This thing is sending out enough ones and zeros, 24 bits per LED. It can update this 1,000 times a second on 1 wire. So a single 1 or 0 is about a microsecond and a half going out over this. And so, yeah, the update rate is still being paused here. It can go so fast streaming these things that they just blur into white. And that's what I did with an FPGA. And what I show my students is I have colored LEDs and they start out really slow scrolling, and it goes faster and faster and faster until it's essentially scrolling faster than the eye can tell. And it looks like a solid white strip. You don't see anything happening in the LEDs. They're just white because they're going through the entire color spectrum faster than you can see. And that's all with 1 wire. It can do that. And that's how you do these Christmas lights. People that have big displays of lights on their house and everything, it's those. They're actually driven by a serial bus that is essentially doing a bit per microsecond and a half. And you can do whole walls, it's 60 times a second, that kind of thing.
Hey, Rick.
Yeah.
The reason I ask about this, I didn't know you knew all that LED serial addressing. I have a 10-foot LED wall. It's 10 foot tall by 6 foot wide, covered with addressable LEDs. And I would like, maybe I can get with you. I don't know if I could bring it to your house, but you give me a crash course of starting programming that because I want to program it to do lots of things.
Yeah, you know, I bet if you have a model number, I have looked at detail in the specs for the LEDs on this strip, and that's how I learned about them. But yeah, we need a part number, and then we can learn about them. And I bet a circuit playground can drive them. Yeah.
I'll see if I can load it up and bring it to you. Maybe
Yeah.
we'll play with it or something.
Any other questions or comments? I'm about to end.
Thank you, sir. This was good.
Okay.
Fantastic presentation, Rick.
Yeah,
Okay,
thanks,
good.
Rick. Appreciate it.
Okay, well, let's see, Matt, do you end the meeting?
I can, yeah.
Yeah, I think you got to turn the recording off
Yep,
and
I
then
will.
end the meeting.
Cool.